Hi, my name is Taylor Kelly, and today I'm going to be showing you how to take these problems right here, turn them into a matrix, and then use Gaussian elimination to get your new matrix in reduced row echelon form. So the first thing we're going to do is we're going to make a matrix. So we're going to make our lines. And then what I'm going to do now is I'm going to name this matrix. So this matrix right here is, we're going to name it matrix A. So now to find out what goes inside our matrix, we're going to use these equations up here. So we see we have three equations, so that means we're going to have 3 rows in our matrix. We also see that each one of our equations has 4 variables. We have the x's, the y's, the z's, and then the answer there at the end. So that means that our matrix is going to have 4 columns. 1, 2, 3, 4. So to find out what numbers need to be placed inside our matrix, we're going to take the coefficients in front of our variables up here. So for example, in front of the x, we know that there's an understood 1 here. So here, there's going to be a 1 in this first spot in our matrix. Here, the x is also, there's going to be an understood 1 in front of this one too. So there's going to go a 1 right there. This one right here, we see that it's -1, so it's going to go right here. And this is going to be our x column. The next variable we have is our y. So this right here is going to be our y column. Up here, we do not even have a variable, so that's going to be an understood 0. Right here, it tells us that there's -5 in front of this y, so that's going to be right here. And then down here, we also see that there's not even a variable, so that's an understood 0. Now, using the same exact things we did for these first two, we're going to move on to the z column. We see up here at this top one that the understood 1, but there's a negative in front of it, so this one's going to be -1. There's not even a variable here, so we know that that's understood 0. And then right here, we see that there is a 5z. So we're just going to take that coefficient and put the 5 right there in our matrix. Then for this last column, we see that it's all zeros, and that's all you have to put in this last column. You're going to take what's after that equal sign and just add it there. So if you remember earlier, I was telling you which one of these was our rows and which were our columns. Well, that information really comes into play when you have a question like this. So starting here, this A, I also named our matrix, matrix A. That just means that the information that this equation is asking is going to come from our matrix A. This 2 right here is going to be our rows column. So as you see in this matrix, I told you that the rows are going to be this one, this one, and this one. Well, if we're looking for our second row, it's going to be this line right here. This 3 right here is telling us our column number. We know that our columns are the up and down ones. So for our third column, it's going to be this row right here. So if this is asking for matrix A on the second row, third column, we know that it's going to be this 0 right here because it is in the second row and in the third column. So the answer to this problem right here is going to be 0. So as you'll see right here, I have a matrix that is in reduced row echelon form. You'll notice that there's 1s in this diagonal row right here, and all the rest of the numbers are 0 except this column right here. It is important to know that this column right here does not have to equal 1 or 0. It can equal any number you want it to be. But these right here either have to be 0 or 1 for this to work. So now what we have to do is we're going to take our matrix A right here that we made earlier with these equations, and we're going to get it to look like this using Gaussian elimination to get it in reduced row echelon form. So our first step is going to be to get a 1 in this position right here. Well, if you look over to our matrix A, we already have a 1 there, so we're set. So what I'm going to do is I'm going to write the first row into our new matrix that we're making. So our next step is to get a 0 in this position right there. If you look over to our matrix, you see we didn't get lucky this time. We have a 1 there. So what we want to do is we just want to take row 1 and cancel out that 1 right there. So how would we get this using this row to make it equal 0? Well, what you can do is you can take -1 and multiply it by row 1, because if you multiply -1 by 1, it's going to give you -1 there. -1 plus 1 is going to equal 0. So we're going to take our negative row 1 and add it to row 2, and that is going to equal our new row 2. So taking this -1 and multiplying it by row 1, we're going to look over. We see we have 1, so 1 times -1 is going to be -1. We have a 0. 0 times -1 is going to equal 0. We have a -1 times a -1. Negative times a negative equals a +1. And then we have another 0. As we saw right here, 0 times -1 is going to equal 0. And then we're going to add row 2 to it. So we're going to take that 1 and our -5, our 0, and our 0, and we're going to add those two together. 0 plus 0 is going to be 0. 0 plus 1, 1. -5 plus 0, -5. And then -1 plus 1 is going to be 0. This is going to be our new row number 2. So we're going to put it in this row 2 spot right here. So we're going to have 0, -5, 1, and 0. Now you see we have a 0 in that spot. Now since you see we didn't use row 3 at all in that equation, so it's just going to stay the same and go right back in its spot. So it's going to be -1, 0, 5, 0. So this is going to be our new matrix for now. What we have to do now is get a 0 in this position right here. As you can see in our equation, or our matrix, we have a -1. So we're going to have to use one of these rows to make that equal 0. So since we're trying to get a 0 in this spot right here, but we have a -1, what can we do to make that equal 0? Well, if you look at our row 1 right here, we have a 1 in that spot. And what does 1 plus -1 equal? 0. So what we're going to do is we're going to take our row 1 and add it to row 3, which is going to equal our new row 3. So taking our row 1, it's going to be 1, 0, -1, and 0. We're going to add our row 3. So we're going to add -1, if I can get my marker to work, 0, 5, 0. 0 plus 0 is 0. 5 plus -1 is going to be 4. 0 plus 0 is 0 again. And then 1 plus -1 is going to be 0. So to make our new matrix, we're going to have our row 1 is going to stay the same. So it's going to be 1, 0, -1, 0. Our row 2, we didn't even touch it this time, so it's also going to stay the same with 0, -5, 1, and 0. Our new row 3 is going to be the 0, 0, 4, 0. So now that I have my matrix right here, I'm just going to jump around a little bit. So we see right here that this needs to be a 1, but down here I have it as a 4. So what can we multiply 4 by to get 1? 1/4. So if we take 1/4 row 3, like that, it's going to be our new row 3. So 0 times 1/4 is of course 0. Again, 0. 4 times 1/4 is going to be 1. And then 0 times 1/4 is going to be 0. So this right here is going to be our new row 3. And how we would write that in our new matrix would be our first row right here going to stay the same. So it's going to be 1, 0, -1, 0. And then our second row is also going to stay the same because we didn't mess with it. So it's going to be 0, -5, 1, 0. For our third row, we just redid that one. So this is going to be our new row 3. So it's going to be 0, 0, 1, 0. So with our new matrix, what we're going to do now is we're going to try to get a 0 in this spot right here. Because over here it's a 0. So how we're going to do that is, if you notice on row 3, we have a 1 here. And if you add 1 to -1, it's going to give you 0. So we're going to take our row 3 and add it to row 1 to equal our new row 1. So what that's going to be is going to be 0, 0, 1, 0. Adding it to 1, 0, negative 1, 0. That's going to give us 1, 0, 0, 0. So our new top row is going to be that 1, 0, 0, 0. Since we didn't touch our second and third rows, they're going to stay the same. So we're going to have 0, negative 5, 1, 0, and 0, 0, 1, 0. So now that we have our new matrix looking like this, what we need to do is we need to get a 0 in this spot right here. Notice how it's a 0 up here, so of course it needs to be a 0 in our new matrix. So our row 3 right here has a 1 in this spot, and we could multiply that 1 by negative 1 to get negative 1. So 1 plus negative 1 would give us our 0 right here. So we're going to take our row 3 and multiply it by negative 1. And then we're going to add our row 2 to it to get our new row 2. So negative 1 times 0 is going to be 0. Again, 0. Negative 1 times 1 is going to give us negative 1. And then, of course, 0 again. To that, we're going to add this row right here. So that's going to give us adding 0, negative 5, 1, 0. 0 plus 0 is 0. 0 plus negative 5 is negative 5. 1 plus negative 1 is going to be 0. And then 0 plus 0, of course, is 0. So, with this being our new row 2, we could make a new matrix with this one. So for our new matrix, our row 1 is going to stay the same because we did not mess with it. Our new row 2 is going to be 0, negative 5, 0, 0. And then our row 3, we didn't mess with it, so it's just going to be the 0, 0, 1, 0. And as you can see, we're getting a little bit closer because they're starting to look more like this one right here. So of course, as you can see, our new matrix is looking a lot like this one, but there's still one thing we're missing. Notice how here in this one right here, it's a 1, but on ours it's a negative 5. We're going to have to get our negative 5 to equal 1. So what can we multiply negative 5 by to get 1? Negative 1/5. So we're going to take our negative 1/5 and multiply it by our row 2. And that's going to give us our new row 2. So if you take negative 1/5 and multiply by 0, it's obviously going to be 0. Negative 1/5 times negative 5 is going to give us 1, and then 0, 0. So this is going to be our new row number 2. So we're going to come over here and make our new matrix. Our first row, we didn't mess with it again, so it's going to stay the same. Our new row 2 is going to be this one right here. So that's going to be 0, 1, 0, 0. And again, we didn't touch our row number 3, so that one's going to stay the same. And if you'll notice, our new matrix looks a whole lot like this one right here. So if we come back over to matrix A, which we made from our equations, and look at our new matrix, we'll realize that we have successfully got our matrix into reduced row echelon form. So we want to know what this information has to tell us. Like, why did we have to do all that work to get it to this format? Well, actually, this right here helps us figure out what the answers to our x, y, and z is going to be. So for example, this first equation, we're going to have our 1x, like we did up there, so it's going to be x. We don't have any y's, so we're not going to add a y, and we don't have any z's, so we're not going to add a z. So that first row tells us that our x variable is going to equal 0. If you look here, we don't have an x, but we have a y. So we're going to have y. We don't have a z, so we're not going to add it to it. So it just tells us that our y is going to equal 0. Same for this one down here, but we don't have an x or a y. We have a z. This tells us that our z is going to equal 0 as well. So we did all of this work just to figure out that our x, z's, and y's are all going to equal 0.